and I'm privileged to extend my warm welcomes to all present here for the Faculty Development Program, Advanced Research Methodology and Data Analysis. I myself, Dr. Razina from School of Economics and Commerce, CMR University, Bengaluru. I welcome all the participants to the FDP. I take privilege to introduce our resource person of the session today. That's Dr. Nishant Kumar sir. Sir is an associate professor in the School of Business and Management, Christ University, Bangalore. During the initial phase of the career, sir has worked with Amity University, Doon University, Delhi Institute of Advanced Studies, HCL, Infosystems Limited, and with more than 12 years of rich experience in academics, research, and corporate, Sir has also worked with an international research projects, namely vulnerability and possible business adoption measures in the Himalayan region, which is funded by Swiss Agency for Development and Cooperation. Dr. Kumar has published over 20 research papers in journals with ABS, Scopus, Web of Sciences, and also ABDC classifications. Sir has also published books, patents, book chapters, and also a member in the editorial review board of journals like Global Business Strategy for Sustainability, Journal of Market Access and Health Policy, Research Journal of Textile and Apparel, Human Behavioral and Emerging Technologies, Innovation, Technological Innovation for Sustainability and Business Growth, and Global Journal for Flexible Systems Management. Sir has presented papers at various national and international conferences in in prestigious institutions like IIM Bangalore, IIM Indore, IIT Roorkee University of Mumbai, and IIT Roorkee and University of Mumbai, and has also won an outstanding research paper awards. Sir's interest and expertise include intelligent computing technologies, blockchain and its application, data analytics, mixed methodology, multivariant statistical analysis, model development and validations using SPSS, PLSM, and MOS. Sir, welcome to our FDP session, sir. Over to you, sir.
Thank you, ma'am. Thank you for the introduction. So we'll start with the session by the topic, which itself is quite interesting and quite multidisciplinary. That is multivariate analytics and exploratory factor analysis, right? So before we go in detail, okay, I'll just share the screen before we start the session, right? So I think I have the right to share it. Yeah. Okay. Fine. So I hope my screen is visible.
Yes, sir.
I've shared the presentation. Fine, fine. Okay. Right. So thank you, ma'am, and thank you all of you for organizing this faculty development program. And I welcome all the participants for today's session. That is multivariate analysis and factor analysis, which is quite popular.
Voice is sir. You are on mute, sir. Sir, you are on mute, sir.
Yeah. Am I audible now?
Yes, sir. Audible.
Yeah, yeah. So thank you so much, ma'am, for the introduction, and warm welcome for all the participants to this faculty development program. The topic is not new to everybody. It's a quite old and a very popular technique still used. I basically, when I look at statistics, especially multivariate data analysis, I look at the classification in terms of generation, right? So if I look at this multivariate analysis, it's into the third generation now, where we talk about structure equation modeling, confirmatory factor analysis, covariance based analysis, and variance based analysis. So many more techniques are there. So what we'll do today, we'll try to have a look at what multivariate analysis is, what is multivariate measurement, what are the different techniques, and then we'll look at factor analysis. We'll try to have a broader view, broader understanding to this particular technique. And then we'll see as the time permits to what extent we grasp this technique and understand its application across different domains, right? So when we talk about these analytics, these tools, these techniques, so there's a very popular statement from Tom Peters, which states that we are drowning into information and starved for knowledge. So everywhere we have information, but driving knowledge from that particular information is a challenge. For that, we need analysis, right? And actually, multivariate analysis helps us in doing the same, right? So going ahead with the same, let's quickly have a look at the agenda for today's session. What is the agenda and how we are going to progress in today's session? So see, looking at the flow of the session, first we'll be having a discussion on multivariate analysis concept. Then we'll look at measurement, classification, then exploratory factor analysis, process, and hands-on exercise related to what we discussed today. So before we go in detail with this particular technique, I just want to understand one thing here. See, if you look at my screen, I highlighted one particular software, JASP, JASP, right? So I just want to understand this particular thing. How many among the participants have ever used this software, JASP? Because today we are going to use it for some of the multivariate analysis. Could you please raise hand or respond in any way that what is the familiarity level with this software? Because we have SPSS and many other tools and techniques. Okay, fine. So I can see one participant. Yeah. What about others? What is the level of familiarity with it? Because quite new, but quite handy. Why I'm talking about it, the reason being that most of the time in FDP we have a constraint in terms of usage of the software, that whether it's a licensed one or paid version. So today we are going to discuss on a software which is totally free, easy to use, right? And all different kind of analysis can be performed with it. So I can see, like, I think one participant raised hand, and no issues. So I'll give you a brief overview to it. Okay, I can see two participants from the total participant. Fine, that's great. Anyways, it's very simple and easy to use. So we'll use the software for multivariate analysis today. I'll give you initial instructions how to download it, and then proceed with today's session with the same software, right? So before we start with the conceptual understanding of multivariate analysis and factor analysis, I expect if you have systems with you, just follow the steps. If you have not downloaded the software, I'll first give you within few minutes, 2 to 3 minutes, if I'll give you an instruction how to download the software, because we are going to use it for today's analysis, and it's very simple. So simply you have to go to Google. I'm doing everything here on the screen, right? You can follow the steps to download the software, right? So go to Google, write down JASP, JASP, right? Software download. Okay, and it's free to use. No payment is required, no license is required by University of Amsterdam. It's free, right? So you'll be getting the first link. Please follow me. If you have not used, no problem. It's very simple and easy to use. If you learn it, then now onwards there is no need for any license software, for especially at the intermediary level of multivariate analysis, right? So you'll get this first link, right? So click on this link, you'll get this page, right? If you have Windows system, click on Windows 64-bit. If you have Mac, Apple MacBook, you can use this, any of these options, depending upon whether you have Intel or Apple Silicon, or if you have a Linux system, you can use any of these options, right? So there are three. If you have Windows, click on it, and the moment you click, it starts, it will start downloading into your system, and you can go ahead with it. So nothing is required. You simply have to download and run it. So by the moment I am going ahead with the session, you can, at the back end, you can click on it and start downloading this software. It will help you in a long way. And anyways, we are going to use it, right? So just click on it and download it. Once it gets downloaded, click on the install option, and whatever instructions you get in front of you, start clicking on it, automatically it will get installed within 5 to 10 minutes, right? So that is one thing. Okay, fine. So now going ahead with the session, first what we will do, we'll have half an hour or 40-minute session based on the conceptual note of multivariate analytics, and then what is measurement, and the different type of models. Once we understand it, then we'll use the software for some sort of analysis as a hands-on session, right? By the time you can download it at the back end, I'll share in the chat, I'll share the data file while we start operation, right, on the software. Okay, fine. So I'll go to the presentation mode again. Okay, fine. So starting with multivariate analysis, as we all know, when we talk about multivariate analysis, what is the use of multivariate analysis? Basically, it refers to all kind of statistical techniques. Generally, when we try to understand it in a layman's language, we generally say that multivariate, where we have more than two variables, right? Two variables or two or more than two variables. Univariate means single variable, right? But that is at a very basic level. When we move deeper into research, it's not only about the involvement of variables, right? It is all about multiple measurements. Okay, multiple measurements, right? So what actually multiple measurement means, we'll talk about it. Okay, so basically when we talk about multivariate analysis, it refers to statistical technique that analyze multiple measurements, and the impact of those multiple measurement on the dependent variable that we generally call as the object under investigation, right? So instead of using the term multiple variables, we use a generic term that is called multiple measurements, and its impact on the object or the investigation on which we are trying to measure the effect, right? But apart from this, there is one more very important concept. When we dig deeper into multivariate analysis, there are many terms we generally come across depending upon the kind of statistical technique we use. That is, we call it as an assumptions behind using any of the technique, right? So basically, if you talk about those assumptions, whether it is multicollinearity, heteroscedasticity, or any kind of assumption, the basic objective is that whenever we go for multivariate analysis, the idea should be the idea or the objective should be like to measure the collaborative, or the sum total impact of those independent variables on the dependent variable. The independent effect, single individual effect, should not be measured. If you are able to measure combined effect of those multiple measurements on the dependent variable, then only we can say it's a multivariate analysis, right? So basically, I'm talking about the relationship, the variance, sharing the variance. So multiple variables should be there in multivariate analysis, but they should also share some sort of variance, right? Now, what is variance and what does sharing of variance means? We'll talk about it in great detail today. Right. So multivariate analysis, basically we talk about impact of multiple measurements on the outcome variable, right? So that is the object under investigation. Like here, I've taken a very simple model from one of my paper published in the year 2022, very simple one, where we talk about the impact. And this is actually derived from theory of planned behavior, where we have like attitude, perceived ease of use, perceived usefulness, impacting purchase intention, and then finally impacting purchase behavior, right? So basically, if I talk about this attitude, ease of use, usefulness, these are what? These are the multiple measurements that I'm having in front of me, right? I'll not say these are multiple variables. These are multiple measurements. Why I'm telling this, these are multiple measurement, because when you talk about, let's say, if I talk about attitude, right? So one way for measuring attitude is simply asking the question, right? In a dichotomous form, either yes or no. But the other way, the broader way, which we generally use when we go for framing an instrument for data collection, is by using multiple dimensions. And generally we call it as an indicators, right? So instead of measuring attitude by simply asking a dichotomous questions, that is yes or no, what we are doing, we are using multiple measurements, that is indicators, like finding the average score among the three measures, that is personalized feature, convenience, and the wide range, right? So these are multiple measurements, and we generally call it as an indicators. Now, why this is important here? The reason behind understanding this multiple measurement is nowadays we talk about multivariate analysis in terms of structure equation modeling. That is very important to understand. Structure equation modeling. Here on the screen, you can see there is, a very simple model which talks about like curiosity, creativity, learning. So here we can see curiosity is one of the variable, creativity is one of the variable, learning is one of the variable. But at the same time, if I talk about this curiosity, or if I talk about this creativity, they are independent variables in this model, right? And learning is your dependent variable in the model. Okay, but at the same time, when you talk about curiosity, this is a variable measured through multiple indicators. Okay, these are the indicators. Here you can see cu1, cu2, 3, 4, 5, right? So these are multiple measurements through which we are measuring curiosity. Actually, what we are doing in multivariate analysis, we are trying to measure the impact of these multiple measurements on the outcome variable. At the same time, here we are talking about creativity as one of the construct. Okay, those who have used structure equation modeling, there is a concept of construct: endogenous construct, exogenous construct. So we call it as an endogenous when it's a dependent variable, and this is your exogenous when it is an independent variable. But what is construct? Construct is a formulation of multiple measurements, right? Where the arrow is going from creativity to these multiple measurements. Okay, so in this model, what actually we are trying to do, we are trying to check the impact of these multiple measurements on the endogenous variable, that is learning. Okay, and that is why it becomes a multivariate analysis. So if you talk about today's context, multivariate analysis not is not about involving multiple variables. We should have a right measurement against those variables, so that we can effectively measure the impact of those multiple measurements on the endogenous variable, and then only we talk about a model, right? So here I can say that this is a covariance based model. Those who have used partial least square, or MOS, that is covariance based or a variance based structure equation modeling, they can easily understand. Here we have a covariance arrow which talks about a covariance base. There is a relationship. Okay, so here what we are having, so if I talk about the relationship between curiosity and these arrows which are going from curiosity, this is a reflective construct. This is a reflective construct. At the same time, creativity is a reflective construct because arrows are going out from the construct. But sometimes what happens, we get a formative construct also in a model, right? So formative reflective model. Okay, so here we are having a multivariate model where, so when we talk about multivariate model, there are two parts to a multivariate model. One is called measurement model and the other one is called structural model. Now, what is measurement model? Measurement model is basically a relationship between construct and the indicators, right? Here you can see curiosity and its indicators. These are the indicators of curiosity. So measurement model is always a relationship between construct and the indicators. Same way, creativity and this indicator relationship, measurement. But when we talk about structural model is basically your path model, right? That is construct relationship. So multivariate modeling is all about understanding this relationship, checking the impact of your exogenous construct on the endogenous construct. I think somebody's mic
Dear
is unmuted.
participants, Nishant sir, your mic is on mute, sir. Nishant sir, can you hear me? Your mic is on mute, sir.
Okay, now am I audible?
Yeah, it's fine, sir. It's fine, sir. Even my mic was muted. Yeah, sir.
I think so. If the hosting rights are given to the organizers, then the
Mhm.
participants by mistake they'll not be able to mute it.
Yeah, sir.
It
Actually,
happens
we
by
have an
mistake.
option of muting all as it
Ah,
is
yeah,
written,
that's
but we
why.
have some queries in between, so we have actually not muted them, sir. Because in
Fine,
between we
perfectly
have
fine.
seen, yeah, that is the reason, sir.
Yeah,
Otherwise, we have
no
an
issues.
option to mute everybody.
Yeah,
Yes,
yeah,
sir.
yeah. It's okay, perfectly fine.
Okay, sir.
Yeah. So
Thank you, sir.
I hope we are clear as of now related with multivariate measurement. So it's all about measuring the impact of multiple measurements on the endogenous construct. So similar examples we can have. So one of my published paper where we measured the impact of uh, socio-demographic indicators, health capacity indicators on healthcare expenditure. So again, if you look at SDI is an exogenous, HSCI, health system capacity indicator, again an exogenous, but healthcare expenditure is an endogenous. Both, all these three are the constructs which are measured again through some indicators, right? So what are those indicators, right? These are multiple measurements. So these are represented here by squares. Okay. So that is what, in simple way, what is multivariate analysis. Now, looking at the classification, how broadly we classify this multivariate analysis technique. If you look at the classification of multivariate analysis technique, so one thing, generally what happens when we start applying tools or technique to statistical data, we struggle in identifying a right technique for our analysis. That is the first challenge in front of any researcher. So for that, what we need to do, we need to understand one thing, what actually we are trying to do. What is the type of relationship is being examined. So whenever we talk about multivariate analysis, it's all about examining the relationship. It's all about examining the relationship, right? So what type of relationship we are trying to examine, whether it's a dependence technique or it's a interdependence technique. So when we talk about dependence technique basically means there is a clear, differentiation between IV and DV, right? Exogenous and endogenous means independent and dependent variable. That's a dependence technique. But when we talk about interdependence, there is no differentiation, no demarcation between your independent variable and the dependent variables. Okay. So that is the basic thing that we should know whenever we talk about application of multivariate technique. What actually we are trying to do, whether we have differentiated our data in terms of independent and dependent variable, or we have a raw data where actually we try to understand the pattern in the data, or we are trying to explore the data. What is our objective? If our objective is to understand the relationship, right, then we'll go for a dependence technique. If our objective is to understand the pattern in the data set or explore the data to identify some or extract some factors out of it, then it's an interdependence technique, right? So that is the first way to classify multivariate analysis techniques. Now, going ahead with this, how many? Now, if I talk about dependence technique, now it depends. Now, dependence technique is again being classified under depending on how many variables are being predicted. So if I have multiple variables, right, multiple relationship of dependent and independent variable, multiple relationship, you are having multiple dependent variables, multiple independent variables, you developed a complex model, you're trying to examine that model. So in that case, the best technique is your SEM, structure equation modeling. That too is being classified under two different types. One is covariance based and the other one is called variance based SEM, right? So for covariance based SIM, the popular is your AMOS by IBM, the software that we use. And there are many other literals and other softwares also. And even this covariance based SIM can be applied to the software that we are going to discuss today. That can also be used for this covariance based SIM. Okay, JASP. And variance based is basically a predictive structure equation based modeling. And there we use smart PLS, right? So there is a lot of difference between the usage of these two techniques, when we should use covariance based and when we should use variance based. So if we go in detail with that, then again, it's a point of discussion, right? So we'll not go in detail with that. That is not the agenda for today's session. But broadly, when we talk of structure equation modeling, blindly we can't apply SEM to any data looking at multiple independent dependent variable. You have to look at our objectives, and then based on that we need to decide whether covariance based or variance based SIM is applicable in this data set, right? Now, the next, several dependent variables in single relationship. Next classification. Okay, so what is the measurement scale of the dependent variable? So if we have several dependent variables, then we need to look at the scales, right? So what are the scales? So when you talk about scale, as we all know, we classify the scales under 4 different heads. That is nominal, ordinal, interval, ratio scales, right? So again, nominal and ordinal is your non-metric scale. Interval and ratio is a metric scale. So depending on this, if you have multiple dependent
Nishant, sir.
variables, yeah,
Sir,
yes.
this is, I'm finding it a bit technical. I don't know about the rest of the participants, but is there any way we can make it simpler to understand?
Okay. Yeah, I'll go into it within 2 minutes. Once we cover it up, then we'll narrow down our discussion purely into EFA, exploratory factor analysis, which is the theme. That would be fine, or directly should we go into it if it
No,
is?
no,
Okay.
I'm fine. We are fine, but just this table also, like
Okay.
broader sense, what we are discussing, I'm finding it a bit disconnected. Although trying my
Okay,
best.
fine. Okay, fine. So I'll try to simplify it in the best way. See, if you talk about this table simply talks about two things. One is when we talk about the classification, multivariate analysis technique. When we are applying any of the technique, we have to look at our objective. What is our objective? Whether we want to do some sort of prediction into the data set, or we want to explore the pattern in the data set, right? So that is the first classification in this table, which this table talks about. If I'm talking about the prediction, prediction means establishing relationship, understanding the relationship, right? And I'm trying to identify number of independent dependent variables. So in that case, we look at this classification, right? This broader idea for this part is for understanding the relationship. But my objective in the research, let's say my objective of the research is skill development. I want to develop a skill, right? So in that case, my data is raw. I'm not trying to examine any kind of relationship between independent and dependent variable, right? So in that particular case, no differentiation of independent and dependent variable. In that case, we go for interdependence technique. That is what this table actually talks about. This table simply says that multivariate technique can be classified into two ways, depending upon the objective. One, whether you want to establish a relationship, or you're trying to understand the pattern. That's it. So again, if we go deeper into it, let's say I'm trying to understand, I'm trying to explain the relationship. Now, how many dependent variable, how many independent variable, what is the nature of the dependent variable? Depending on that, we are having different techniques. This is what the left side, this one is. If you have multiple dependent independent variable connected to each other, structure equation modeling, one technique. If you are having multiple dependent variable, then we have different techniques depending upon the nature of the scale, metric and non-metric scale, canonical correlation, or we have multivariate technique, manova and all. So that is the classification, right? And similarly, on the right hand side, what we are having, we are having very popular techniques, that is called factor analysis, EFA, CFA, right? Cluster analysis, multidimensional scaling, correspondence analysis. So when we talk about these techniques are interdependence technique, where we don't have a demarcation between dependent and independent variable, right? So this is a broad classification. Since we are not covering, and it's not possible to cover all the techniques in one go, just it's a broader idea, so that we all should be on the same page that what actually we are doing today, right? Now what we are going to discuss today is, we are going to discuss an interdependence technique, and that too factor analysis, right? And if the time permits, I'll show that how the result from the factor analysis can be used under the dependence technique, that is multiple regression. Okay, so that is what this classification is. Okay, now let's
Thank you,
start the
sir.
session with, yeah, I hope it's clear now. Okay, so we'll start the session with the one technique that we are having today, that is EFA, exploratory factor analysis. Okay, so as the name reflects, exploratory. Since if you look at research, And if anybody is having any question or query, please unmute and ask immediately within the session. I will not mind, because I can't see the participant list on my screen, right? So please unmute, feel free to ask question anytime during the session. Okay, so when we talk about exploratory factor analysis, as the name reflects, it
Excuse
depends
me,
on
sir.
yes, please.
Sir, actually, you explained multivariate analysis. Now, I come from statistical backgrounds. We mostly tackle the problems in terms of multivariate statistical analysis, and we try to understand the factors and their uh, altogether regression. Regression. So that is what we see. So,
Mm-hmm.
and you have given a broad picture of that multivariate analysis in different formats. So that was
Mm-hmm.
interesting. So, like as we see functions, like I will come from the statistical background that we see multivariable function in relation to the outcome variable. Then we try to see the relationships, right? Indirect or direct relationship in this
Yes.
process.
Yeah. Could you please come again with your question?
I'm saying, sir, if we talk about this multivariate analysis, which you have just explained, now
Mm-hmm.
come from little statistical background, so we see this as a regression analysis type of thing. Which is further, if we
Mm-hmm.
have more independent variables and more complex constructs, we will go to SEM, structural equation modeling. So we try to see
Correct.
in all scenarios relationships, right? Indirect or direct relationships
Correct.
in the regressors,
Right.
right, sir?
Yeah. So, but so this is what I actually explained. When you talk about multivariate analysis, no,
Hmm.
what actually you're talking about, that is one part of multivariate analysis. When you
Correct.
talk about regression, establishing relationship, or examining the impact. Okay. But apart from that, the other vertical for multivariate analysis is when we don't have a differentiation of independent variable. If you don't have a differentiation of IV and DV, then also we can apply some of the multivariate analysis.
Mean to say that latent variables are visible, latent variables are seen that time, and then we will apply that factor. I mean, understanding the variables first. Also,
See, yes. So in that case, there are two things again.
Mhm.
One is, like you mentioned, latent variables are visible. That is a priori knowledge. You are having a priori knowledge, right?
Correct, sir.
And then at that, if you have a prior knowledge in the data related to the latent variables, that these
Yes.
many variables are there, then in that case, directly you'll pick those variables from the literature, and you'll go ahead with, again, cause and effect relationship, checking the impact and all these things.
Excuse me, sir. Just
Yeah.
excuse me, sir. Mr. Ramarao, can you keep your video off? Mr. Ramarao, can you hear me? N. Ramarao. There is a disturbance this video, sir. I'm just trying to.
Yeah.
Yeah, Mr. Ramarao. I don't know, sir, whether it's even being part of this session or not.
Is there a way the host can disable the video?
Actually, that writes. I will talk to sir once, Sunil. I'll talk. Sunil Gupta, I'll talk to sir. Okay. Please continue, sir. This I'm
Yeah,
trying
yeah.
to.
So,
Yeah.
yeah, fine. So actually, I was just answering the same question that we discussed there. That if latent variables are visible to us and we know these are the latent variables, then again there is no point in going for EFA. We can directly extract those factors or variables from the literature, and then we can go for regressing it. But what we are going to discuss today is, sometime what happens, we have data set and we don't know what factors are there in the data set. We are actually trying to explore that. Probably once we explore it, then we can go for regressing it. So that is again one of
What
the dimension under multivariate analysis.
Sir, what I meant actually that when we have this latent variable, a set of parameters which we have picked up from the literature, then we
Mm-hmm.
might also see the scree plot. using dimension
This is
reduction so that we
constant
check
comparison,
whether there is
Manoj.
overlapping or we have only unique variables.
Fine, you can do that. We can do that, right? But
Yes.
what actually I'm trying to say, see, the usage of factor analysis is quite diverse. What if you have a latent variable from the literature? If you know these are the variables from the literature, right? And what is the objective? The objective is you'll pull those variables and probably you'll try to examine or test some relationship, right? That's why you are extracting some variables
Yes.
from the literature. Okay,
Yes.
that is the general idea. What if you don't know what all factors are there in the literature? What all variables are there?
Okay.
So that
Right.
is one of the idea behind using multivariate
Nishant
modeling.
sir, just 1 minute. Yan
Yes, sir.
Rama Rao, please mute your camera. Please close your camera, please. Yan Rama Rao.
Thank you, Nishant sir. I've got answer.
Yeah.
I've understood like what you're referring to.
Yeah,
That
yeah. We'll go ahead
understanding
with the
the
session. Probably then at that time, it would be more clear that what actually
Yan
we are
Rama
doing.
Rao, please close your camera. Okay, sir, please continue. I will remove
Okay,
him.
fine. So we'll try to quickly cover the idea behind it, and then we'll try to spend more time on hands-on. Okay, so basically we discussed this classification. No, I'm trying to cover here this part. Let me clear very strictly that what I'm trying to do today. I'm trying to cover this particular part, not this one left side where we talk about regression, SEM, and all these stuff. Because there we know all these things are very clear in the literature. What if we don't know what is there in the literature? It's quite vague,
correct, sir. Correct.
right? Right. So we are trying to do that. That very popular one is EFA. So when we talk about EFA, what is the approach? Like somebody mentioned just now, dimension reduction, right? Dimension reduction. But is it always that we use EFA to reduce the dimensions, or we try to summarize the dimensions? Okay, so let's try to understand the idea behind EFA first. What is the idea of using exploratory factor analysis? So the idea behind using EFA actually brings us back to the broad classification of research design. If we look into the classification of research design, we have very broader way: exploratory, descriptive, and causal. Or if you look at Naresh Malhotra's marketing research book, he classified as exploratory and conclusive, under conclusive, descriptive, and causal, right? So but exploratory is something which is very much generally, not always, is generally most of the time is qualitative in nature, right? And where we have a lot many dimensions, we have lot many statements, lot many indicators, and we just want to bring it to a certain justified level so that we can carry out our research. So the approach is very clear. When the area is not clear, we want to structure it, we want to give dimension to it, we want to give direction to it, either through summarization or through reduction. Both are different things. Dimension reduction is different, data summarization is different, right? So we'll talk about it. We use different techniques, and the ultimate idea is to give direction to research, to reduce the number of statements, to confine our research into particular direction. Okay, so if you look at EFA and CFA, what is the difference between EFA and CFA? Exploratory factor analysis and confirmatory factor analysis. So if I look at exploratory factor analysis, like we discussed, here the idea is to reduce the number of statements, number of variables, and very popularly it's used for skill development, or whenever we start our PhD, we design questionnaire, and our questionnaire is like 50 questions, 80 questions, 100 questions. We go for pilot testing. Okay, and then we try to reduce it. We do calculate communalities, we go for many things. Okay, so dimension reduction, factor analysis, and through that we get set of factors. Based on the relationship between the variables, we try to name the factor. So what is factor? Basically, factor is a linear combination of variables, right? So and what is linear combination? Linear combination basically means correlation value. And what is correlation? Shared variance, right? So it's everything is interlinked to each other. But the ultimate idea is to reduce the set of statements, or giving a direction from a blur or a blur background and giving it to a confined way, EFA, right? But at the same time, CFA, like gentleman right now mentioned, that when we identify statements from literature, we directly go to regress it through uh, structure equation modeling or regression and all. So basically there we are very clear when we talk about CFA, confirmatory factor analysis. There we are very clear, these are the statements and these are the dimensions that we have. We want to check its impact. And it's not always mandatory that you should use CFA after EFA, right? Because EFA is a very unique kind of technique and it's have a very limited scope in terms of research. When we are trying to do something innovative or new in terms of scale development, in terms of idea generation, and the idea is not very clear in literature, then only you should go for EFA and then bring CFA in picture. If you are very clear that, let's say I talk about a model like a theory of planned behavior, a technology adoption model, very popular model, U2AT. All these models are very popular in research now. You can see many papers where authors use these models modified in study context and published paper. They directly applied confirmatory factor analysis, right? No need for EFA, right? So it's not always that we should use EFA, because the idea is different. EFA is used when the literature is not clear. We have many statements, many dimensions to bring it to some set of factors, and then you want to regress it to develop a model. But CFA, when the idea is very clear, let's say I'm using the theory of planned behavior, adding some cultural dimension into it, modifying the model, and I want to test it in a new environmental condition, no need for EFA, because the variables are predefined in literature. We can directly go for confirmatory factor analysis, right? So for CFA, we have two techniques like we discussed, that is covariance based structure equation modeling or variance based structure equation modeling, right? Now, like we discussed, EFA, which is more of a raw technique. So what is the basic use? Like repeatedly I was telling, scale development. So this is one of the paper which I have taken here as a reference, and is a very a landmark study in this domain, a measure of throughput, orientation, scale development, nomological validity, which clearly talks about that how EFA can be effectively used for developing a scale. We are having many scales in different domains. Like for measuring personality, we are having certain scale. For measuring the quality of service, we are having certain scale by Parshuraman and all, right? So those scale development actually has gone through these many stages, right? Where you get data from experts, you get data from customers, you try to refine that data, confine that data, and then you try to reduce those number of dimensions, right? And then finally we apply exploratory factor analysis, and then finally we go to confirmatory factor analysis. So this is how these are linked to each other. But exploratory factor analysis should be used in specific conditions, when we are having number of dimensions and we are actually trying to reduce those number of dimensions, and that should be followed. And if you want to validate that, right, those validation actually required CFA, and we are having different matrices and dimensions to it. Okay. Now, EFA process. What is the process for conducting exploratory factor analysis? Before we go in detail with the hands-on exercise for EFA, see, it's a 6-stage process when we apply exploratory factor analysis. First one is the objective of factor analysis. What is the objective? What actually we are trying to do through EFA, right? Second, designing a factor analysis. So there are different techniques for designing a factor analysis, which technique we are going to use. And there are different conditions for using a particular technique. If you people have used EFA, you would have seen, let's say, very popular software, SPSS, when you go to Windows or JMP or any software, they ask for many options, right? Which kind of criteria you want to apply, whether you want to go for maximum likelihood, or we want to go for principal access factoring, okay, which method you want to use. So we have to design, and for that we should know in the back end what actually we are trying to do. So we'll talk about it. Then there are certain assumptions for running EFA, exploratory factor analysis. We'll talk about that. Fourth stage, driving factors and assessment or overall fit. We have to drive factors, we have to name the factors, and we have to see how these factors are related. So this overall fit can be checked through another technique called parallel analysis. There is a technique. Generally, what we do, we run EFA, and whatever we get through EFA, we take those factors and we run CFA. And when we are running CFA with those factors, we are not getting great results as expected. Why? Because EFA is not a very robust technique. whatever factors you get through EFA, that needs to be validated. So that can be validated through parallel analysis, which is a Monte Carlo simulation technique. Earlier, there are softwares like in SPSS, directly you can't apply parallel analysis. You get factors and then there are some plugins that you have to use. But JASP, which we are going to discuss today, there we have everything inbuilt, which evaluate the factors based on the eigenvalues, and directly it drives the factors, right? So that needs to be validated. That's a very important thing. And then finally we interpret those factors, and then last stage, this talks about the usage of those factors, right? So how those factors can be used, whether those factors can be used for developing a model, CFA, fair enough, whether those factors can be used for developing a cause and effect model, that is regression, or anything else, right? Now, before we go in detail with this, one thing that we should understand is, whenever we talk about factor analysis, which generally we say is a dimension reduction technique, the first thing is the objective. Dimension reduction can be applied on respondents also. It can be applied on the instrument that you design for data collection also. So these are two aspects that we should always understand when we are using factor analysis. The first is, when you are applying dimension reduction to the research instrument. What is research instrument? Let's say the questionnaire. Questionnaire is a research instrument, right? So when we are applying factor analysis to questionnaire, then that is a R factor analysis. That is a R factor analysis, right?
I think I'm just preparing for class.
Okay.
No, for
So,
tomorrow.
I think somebody's mic is unmute. So please mute yourself. If you have some questions, so most welcome. Right. And the other one is Q factor analysis. So there are two different types of factor analysis we should understand. One is R factor analysis, means dimension reduction applied to the research instrument, like questionnaire, where you want to reduce the number of statements and all. What is Q factor analysis? Q factor analysis is cluster analysis, where you want to cluster, the respondents into group based on their, usage behavior or something like that. So when you talk about interdependence technique in the classification, you would have seen like factor analysis is there, cluster analysis is there, multi-dimensional scaling, many different techniques are there. So when we talk about EFA is R factor analysis, because you're talking about dimension reduction on a research instrument. Q factor analysis is again a dimension reduction technique, but that is mainly a segmentation technique, right? Dividing, let's say you're circulating a product in the market. You want to understand what are the different type of consumers exist in the market related to that product. Some would be heavy users, some would be moderate users, some would be light user of the product. So basically what you're doing, you're trying to segregate your customers. So there EFA can't be applied, because you're trying to segregate, you're trying to develop clusters. So that is Q factor analysis, that is cluster analysis, right? So the objective needs to be very clear, what actually you're trying to do in dimension reduction. Next idea, when we talk about factor analysis again talks about two things: data summarization and data reduction. Now, what is the difference between data summarization and data reduction? Data summarization basically talks about, eliminating some of the statements which are redundant, having same meaning, clubbing it and trying to develop or trying to give it a name, right? So, and try to develop a construct. So construct basically a combination of indicators and statements. So these are many statements that we can see here. I shop for specials. I usually look for lowest possible price, all these things. So all these things talk about simple thing, one particular element, that is price consciousness, right? So that is data summarization. But you are actually clubbing it on the basis of some mathematical values, which we call it as factor loading in factor analysis. That is the value of correlation, and that is data reduction. So why we are telling EFA is a data reduction technique? Because it summarizes the data based on the value of correlation. It reduces, it eliminates the statements which are having low factor loading. There is a rule of thumb like 0.5 should be the benchmark or threshold for elimination, 0.4 or 0.5. Most of the time we use 0.5. So this statement could be eliminated, right? So there is a difference between data summarization and reduction. Summarization is basically a clubbing of statements to name a factor, but how you are clubbing it, is reduction. So basically data summarization leads to data reduction. That's why EFA is known as data reduction technique, where we use some mathematical values to reduce those statements, right? The next stage in the factor analysis is designing a factor analysis, right? So choice of correlation among variables or respondents, uh, what is the use, what kind of variables that you are going to use. Most of the time we use metric variables, right? Metric variables are always preferred in factor analysis, that is interval and ratio scale variables. If we have categorical variables, then generally we say factor analysis can't be applied, but that is not right. If we dig deeper into this technique, we'll understand that factor analysis can be applied to non-metric variables also, like categorical, nominal, ordinal variables. Okay, but that should be converted to dummy variables. That is Boolean factor analysis. This is a different technique by converting it to dummy code of 0 and 1, and that's a bit complicated technique. That's why we prefer to have a metric variable. Okay. Second, how many variables we should have? Response against a variable. One variable should have at least 10 responses, 8 to 10 responses. So if we talk about factor analysis, let's say there are 10 questions in your questionnaire. So what would be the ideal sample size? The ideal sample size would be 10 questions multiplied by 10 responses. You should have at least 100 responses. Then only you can run factor analysis. Some author says that you can run it on 8 also, 7 also, but when you're running factor analysis, we have to check measure of sampling adequacy, right? MSA that we get, and that actually depends upon this. So if your MSA is not getting correct, you have to work on this ratio, this dimension, right? Fine. So assumptions like there's a basic assumption that underlying structure doesn't exist. There is no structure, like we discussed, exploratory. We are trying to explore the relationship in the data set. There is no structure, and there is departure from normality. Normality is not basically an assumption when we are running factor analysis, or heteroscedasticity or linearity. These are not the assumptions, but to some extent, we prefer multicollinearity. I'll talk about it. What is multicollinearity and why we are preferring it? So to some degree of multicollinearity is very important. If there is no multicollinear, means no relationship among factors, some sort of relationship is required, right? Then only we can go for covariance based factor analysis. Okay, and then we talk about overall measure of intercorrelation. That is this all we'll see when we are running factor analysis. Everything I'll explain over there. That is data metrics, sufficient correlation that needs to be there. We should have weak or moderate correlation among variables, not very high correlation. If there is very high correlation, then it's a problem of redundancy or multicollinearity, right? So that we have to take care of. Okay, overall measure of sampling adequacy. So sampling adequacy, the threshold value is 0.5. If you are getting a value of MSA more than 0.5, then we see that the sample size is accurate. Like we mentioned, that 10 statements, 100 responses. If you have less, then this MSA value will go down. I'll show all these things in the data set, so don't worry. It's just a brief idea about what all is there in factor analysis. So 0.5 and all these things. How to increase MSA? If your MSA is less, then you should work on these dimensions. Like the best way to increase MSA is to increase your sample size. Automatically, everything will go up. Okay. And then in factor analysis, there is a very popular term called factor loading. What is factor loading? Generally, we say it's correlation. But what is correlation? Let's say factor is basically a combination of variables, right? There are different variables which get combined, and then we develop a factor. Now, why these variables are getting combined? Because they are sharing their variance, right? And we square it, we get a value of correlation. So there are three different type of variance among variables in factor analysis. One is called common variance, specific variance, error variance, right? The common variance is your communality. Okay, so common variance is something which is being shared. The better the common variance is shared, see, if there are 4 statements which are coming there under one factor, that means they are sharing variance. That is communality. Okay, unique variance is the variance of that particular variable. Error is because of some error terms or randomness in the data set. So total variance is a combination of all these things, right? So our idea should be, whenever we are running factor analysis, we always work on this particular part, common variance. We look at common variance because this is something which develops factor. If there is high specific variance and error variance, you'll never get factor. Generally what happens, we collect data, or when we run factor analysis, we are not getting factors. Why we are not getting ideal factors? Because there is high specific variance and error variance in your data set. Why it is high? Again, it is linked with your descriptive statistics, where we talk about standard deviation. You have to check standard deviation, we need to check the skewness curtices. When we work on it, automatically common variance will increase. Okay, now again, driving factors, how we can drive factors. There are two popular techniques in factor analysis. One is called principal component analysis, and the other one is common factor analysis. Principal component analysis is more popular, PCA, because it works on total variance, right? And PCA is mainly used when the idea is dimension reduction. Most of the time in the area of social sciences, economics, humanities, we use factor analysis to reduce the statements. That is a dimension reduction technique. Okay, so if our idea is to reduce the number of factors, and some of the prior knowledge suggests that specific or error variance is there, small proportion is there in the total variance, we can go for PCA. Common factor analysis actually works on shared variance, the first variance, right? And here the idea is to identify the latent dimensions or constructs, right? So you already have some sort of knowledge related to the data, right? There are 3 or 4 different 5 of factors. So if you know that these many factors exist in this data, we should go for common factor analysis. If we don't have any idea, we should go for PCA, principal component analysis. That is how we should choose between these two techniques. And how these two techniques differs, the PCA, why it's more popular? PCA is more popular because it works on total variance, right? Common factor analysis mainly works on shared variance. So if you have a better understanding, let's say you know that your data involves 4 factors. So while you're running factor analysis, you say 4 factors I need, common factor analysis, and purely it will work on shared variance, right? So that is a basic understanding that how we should choose it. And then the criteria. Now this is something which is very confusing among many researchers, that which method I should use when I'm running factor analysis. And what is the criteria for determining number of factors? There are many criteria that we can see, but we should understand one few criteria which are very important for running factor analysis. One is called latent root criteria, which depends upon eigenvalue. So latent root is an eigenvalue which is 1. If the value is any factor having value more than 1, we choose that factor. That is explaining more variance. Okay. Prior criteria, where we have prior knowledge related to the data, how many factors, how to extract factors, right? I need 4 factors, no problem. Once I get 4 factor, no need to look at latent criteria because I have a prior knowledge, right? Percentage variance criteria, cumulative percentage. If 3 factors are contributing more than 60%, I'll choose those 3 factors. So that is percentage variance criteria. I'm not looking at latent root criteria or prior knowledge, simply looking at variance. Scree plot. Somebody mentioned about scree plot. So again, scree plot is an indication about where we are getting the elbow, where we are getting the curve. Wherever we are getting the curve, those 2 factors can be chosen. And the last one is heterogeneity of the respondents. When you know this data is quite heterogeneous, and first factor explain most of the variance, so there we choose the surrogate variable. So most of the time we work on the latent root criteria, that is looking at the eigenvalue, and in some softwares is by default. Now interpreting the factors, how we are going to interpret the factor? Very simple. We run factor analysis, we get factors, we name those factors, and then once we name those factors, but before naming the factor, we need to rotate the factors. Okay, so what is factor rotation? To get a better orientation of variables on the different axes. Okay, across different axes, we need to have a different orientation. So I'll not go in detail with all the different kind of rotations. Why? First thing is, once you get factor, we need to rotate the factors to have a right alignment of the variables across the factors. So what are the different types of rotation? There are 2 different types of rotation. One is called orthogonal and the other one is called oblique, right? So you might be knowing what is orthogonal rotation when the rotation is being done on 90-degree, oblique when it's other than 90-degree, right? So basically, orthogonal rotation in layman's language, orthogonal rotation is most widely used because the idea behind using orthogonal rotation is to get minimum number of factors with maximum statements, right? So it gives you minimum number of factors with maximum allocation of the variables. But when you talk about oblique rotation, the idea behind using oblique rotation is to explore the theory, statements, and to extract some constructs or factors. And where we say the factors are totally uncorrelated to each other, right? So whether if factors are related to each other, we'll go for orthogonal rotation. If we know the factors are unrelated, we'll go for oblique rotation. And under orthogonal, we are having different quadrimax, varimax, equimax, oblique. Most of the software by default they choose orthogonal rotation because it's presumed that if you are running factor analysis, there should be some sort of relationship among factors, right? And based on that we'll do the load distribution. So varimax rotation, quadrimax rotation, equimax. So varimax is very popular because it independently rotate all the factors. Quadrimax, it distribute the variables across the factors. Okay, we'll look at it once we'll go in detail with the data. So I'll not take much of time now on theory. I'll quickly take you to the data set and the software that we installed and we are going to use it, right? Before we use it, just understand one basic thing. If you are using some other softwares like SPSS or SAS or R, most of the time we identify these two terms, whether I'm going for my maximum likelihood or principal access factoring, right? Which technique I should use for factor analysis. So the best way to understand is that if you have a normal data, normality is there, we can go for maximum likelihood. If there is violation of normality, we can go for principal access factoring, right? So that is the basic idea behind using any of the techniques. So I'll take you to the factor analysis part and we'll discuss everything over there. Whatever we discuss in the theory, we'll apply it on the data set and we'll use it. So okay, so how many of you have installed JASP? Shall we do something on JASP? Should I open JASP? If you have installed it, so that hands-on we can do parallelly something in this session.
So we have.
Okay, fine. So I'll just open it and then we'll start working on it. If there is an option for sharing a data file, I'll share the data file now so that we can parallelly do some hands-on exercise here. Let me check. Organizers, do we have an option of chat here where I can share some data file? Ma'am, do we have an option to share some of the data files here?
No, sir. You can you send it to me in the on the WhatsApp. I will share it.
WhatsApp. Okay. Okay, fine. So I'll send it to you. So give me a moment. I'll just share one file. It's one file. By that time, those who have not installed the software, please install it because it's a very simple and easy software. Again, I'm telling. If you know it, it will be helping you a lot. And it's a very powerful software in all terms. Okay, sir, I've shared the data file with you on WhatsApp, sir. So please put it in the group where all participants are. It's a CSV file anybody can open in their system. No specific requirement.
Shared, sir.
Shared? Okay. I hope you all got it on the WhatsApp. Fine.
It's a CSV file I have shared.
Yeah. Okay. Fine. Fine. So let me brief you about the data file first, what the data file is, before we go in detail with the analysis part. What we are going to do now, we'll be using JASP for exploratory factor analysis, right? And we'll be understanding different values, different things. So for that, we have a problem with us right now. Okay, we are having a data set related to a case. What is the case? Case is this one. Please pay attention here on the screen. Okay, so data file which we all got in the WhatsApp, that is basically a study that was conducted to determine factors responsible for measuring the satisfaction levels among consumers of aerated drinks. Okay, a survey was conducted with a sample size of 100 consumers of soft drinks from different age and income groups. The respondents were a mix of male and female. Some of the questions asked in the survey were as follows. So when you open the data file, in data file you'll find out there are columns named x1 x2 up to x10 and s. Okay, what are those x1 x2 x10? These are x1 means, so the study was conducted related to aerated soft drink, right? So x1 means aerated soft drinks are refreshing. So we are having set of statements. So a questionnaire was designed to understand consumer perception toward aerated soft drink. Okay. And there are total 10 questions and one question related to their satisfaction. Okay. So first question, aerated soft drinks are refreshing. That is X1. Aerated soft drinks are bad for health. X2. Very convenient to serve. X3. Should be avoided with age. X4. Very tasty. X5. Are not good for children. X6. Should be consumed occasionally. X7. Should not be taken in large quantity. X8. Are not as good as energy drink. X9. Are better than fruit juices. X10. Right? So these are the 10 questions which were used to understand the perception of consumers related to aerated soft drink. And there is one more question related to their satisfaction. Would you recommend this aerated drink, soft drink, to anyone? Right? So this is the next question. And all questions were measured on a 5-point Likert scale, 1, 2, 3, 4, 5. Okay, that is strongly. 1 means strongly agree, 5 means strongly disagree. I have taken this data file from one book of research methodology, that is Deepak Chawla and Nina Sondhi research methodology, right? From there, I have taken this data file for this exercise. Okay, now, so looking at this, now we'll go to the software and relate. Now, what response? So response was collected from the respondents and the data was captured in that CSV file. So that CSV file is a response sheet after the survey related to these 10 questions and one question related to satisfaction. What is our objective? What actually we are trying to do? Now, the problem here is we want to understand the factors behind choosing soft drink. What are the concerns of consumer related to soft drink? There are 10 different questions talking about 10 different things. But what are those factors on the basis of which consumers are preferring soft drink? Or when they are consuming soft drink, what are those concerns in their mind? Right? What they feel? What are the factors which affect their choice for the soft drink? We are trying to understand those factors. Right? So for that, we can use factor analysis. So there are total 10 statements. Now I'll open the software and expect all of you to open the same software, JASP. If you have added it, you'll get an icon like this, which I shared here on the screen. JSP 0.18.10, 18th version. Double click on the software. Okay. So the moment you click on it, you'll get a window like this. I hope you got it. If you have any concerns or queries, any question, please unmute and ask. So this is the home page of the software. Let me introduce you with this software. If you have not used, if you have used, fine. If you have not used, I'll give you a brief overview of the software. See, this is a free software, like you can see here on the screen. Friendly, very easy to use, and this is a drag and drop software. No coding, nothing is required. Simply drag and drop, and flexible. No, you don't have to, change your window, go to the output sheet, something like that. Nothing is required. Everything can be done in one place, and immediately you can see the results, right? Here you can see a screen like this. On the right hand side there is a plus option, right? This plus icon on the right hand side. When you click on it, you can see many options here. Acceptance sampling, audit, Bain, BSTS, circular statistics, Gaussian meta-analysis, GAGS, machine learning, meta-analysis, network, power, predictive analytics. It's a very powerful software. Even you can run structural equation modeling, time series, visual modeling. You can connect R console data also, right? Whichever thing you want to add into your top toolbar, the top bar, you have to click on it. Let's say I want to add this reliability. Okay, so I have to click on it. The moment I click, automatically you can see it get added. So that is the use of this. Whatever you want, you have to click, automatically it would be added, right? This way. Fine. So that is the first thing. Now, first what you have to do, we have to link the data. We have to add data for any kind of analysis. Right now you can see all these options are not visible, right? These are visible, but you can't click and start operation. Like descriptive, T, ANOVA, mixed model, regression, all these are not activated. The moment you connect data, automatically these options will get activated, right? So for connecting data, what you have to do, it's a very simple software. There is a 3-dot option here on the left hand side. 3 dots, click on it, right? Once you click on it, you'll get an option called open. Place your cursor on open, then recent file. So this is an option to load your data to this software. Now, which format of data? Almost all formats are supported here. CSV, if you have SAV, if you have SPSS file, that too can be uploaded. Excel, right? Means almost if you have data from R console, that too can be uploaded. But CSV is recommended. Okay. Now, open, click on open, and then I'll go to my computer. Wherever I have saved the file, I'll go there, right? I'll go to browse, right? So on desktop, I have one folder where I have saved this data, the data which I shared with you, aerated drain copy. This is the name of the data file. Okay. And here you can see data set, JASP, what all, format is supported here. Everything you can see here, .csv, text, TSV, and all of formats, right? So this is already a CSV format, right? Aerated drain copy. Okay, selected and then open. The moment you click on open, the data got uploaded here. Fine. We have this data. Now you can see what this data is. We have respondent number, no use, just for the referencing. So what is the sample size here? Can anyone respond? Can anyone tell me what is the sample size in this study?
100.
Yeah, it's 100. We are having data from 100 people here, right? Now, X1, X2, X3, these are what? Statements. Like I have shown, this statements, X1 to X10. Okay, all these 10 and S. Okay, now what is this HRC, BPCF? I'll talk about it later. What is this? Okay, so leave it as of now. Just focus on X1 to X10. Okay, and what is S? S is satisfaction. Now satisfaction, if you look at it, satisfaction is mainly a dependent variable, which is an outcome variable. But factors will lead to satisfaction. That is recommendation. Okay, so that is a general understanding. Now what we are going to do, we are going to run factor analysis. For factor analysis, there is an option called factor here. You can see at the top. There's an arrow, click on it. Now, here we are having 3 options: principal component analysis, PCA, exploratory factor analysis, confirmatory factor analysis. Okay, so we are going to use principal component analysis. If you remember component analysis, where our objective is data reduction, We don't know about much about the normality. Okay. So we'll use PCA, which is most preferably used for developing factor for dimension reduction and for distribution of statements across different variables. Okay. We can't use CFA now because we are not done with the factor models as of now. Okay. So we'll use PCA. So the moment you click on PCA, you'll get a window like this in front of you. Okay. Right. Now what we have to do, here at the top, you can see some options. R syntax, you can merge. Edit the title of this analysis. If you want to give some name to the analysis, that can be done. If you want to duplicate this analysis, you want to create one more tab, that can be done. If you don't know much about this analysis, if you want to know more about what all these options are here, you can see some boxes, no, parallel analysis. You want to know more about it, click on this. Here we already have a ready-made guide. You can see everything is mentioned here. If you have not followed what we discussed today in the theory, you read it, you'll get to know. Right? Everything is detailed here. So it's basically a ready-made guide related to all options which are there. What does Varimax rotation means, Quatermax, Bennett, Equimax, right? Everything is here. If you know, fine. Okay, so that's the brief. And this you'll get with all tools in this software. Okay, now we'll go to factor analysis. So there are question 1 to 10. We'll choose all 10 questions. So for choosing, what you can do, individually also what you can do, you can select and move it to the right hand box. The way we are using SPSS, no, same way we are using the software also. You have to select the variable and click on the center button. Automatically, you have to move the variable from left hand side to right hand side. Okay, so double click on this. Simply double click or select all the statements together. All statements got selected together, 1 to 10. Right? Done. The moment you transfer your statements here, no, automatically you can see the results. You don't have to move to any of the window. But yes, we have to look at the settings also. Okay. Now see, as of now, let's say we talk about eigenvalue. We want to extract factors based on eigenvalue. Okay. And then manually also, if you know that you want 3 or 4 factors, manually you can do changes here. But I don't know how many factors are there, so I'll put on eigenvalue 1. Then rotation, like we discussed, orthogonal and oblique. So orthogonal is more preferred with Varimax rotation, right? So that we can get independent factors. Okay, independent factors where we should have a different set of variables. Okay, I want to have correlation matrix, that is there. So I selected, I can see the results on the right hand side. But after that also we have certain options here, that is output option. Now, if you remember, there is an option of setting factor loading. If you look at literature, factor analysis states that the factor loading should be, in general, we should put a threshold of 0.5. So here it's 0.4. The result which you are getting is on the basis of 0.4. So we'll change it to 0.5, 0.4 to 6. I'll just drag it to 0.5, or I'll change it here only. Okay, 0.5, right? Okay, 0.5. Now, what else I need? I want to do parallel analysis. If you remember, what is parallel analysis? Whatever factors we get here, no, that factors would be validated. There's an extra step where we validate it against their residuals. If we are using SPSS, yes.
Sir, sorry to interrupt. Can you repeat this again?
Which
display loading above?
From starting?
No, sir. From the display loading above.
Okay, this one. Okay, yeah.
Yeah.
Display loading. So here actually we have a threshold. Literature states that the factor loading should have a value either 0.5 or more than 0.5. You should retain that only. So what we did, we change it to 0.5. Okay. Either you can manually enter 0.5 or you can, just scroll it. That will also adjust.
Okay, sir. Thank
so
you.
okay. So that is factor loading 0.5. And then order, component loading, component size, nothing is required. I want, scree plot, very popular. But apart from that, this software also gives you path diagram, right? Path diagram you will not get in any other software, SPSS and all. This generates path diagram, which is quite interesting also. You don't always have to look at the tables and all. Okay, so I'll talk about it. And then apart from that, there are other methods also. KMO, Bartlett's test of specificity, and Mardia's test, which talks about normality. Okay, so just refer to the boxes that I clicked. Initially, I clicked on eigenvalue. I need a eigenvalue 1 or more. I'm going for Varimax rotation. I need a correlation matrix. Whichever is highlighted in blue, the options, no, I'm going with that options only. Now display loading 0.5, component size. I need part diagram, scree plot. Okay. And then KMO, Bartlett's test of specificity, sampling adequacy, Bartlett's test of sampling adequacy, that is KMO, Kaiser, Merrill, Auckland test, and then Mardia's test. This is for normality. Okay. And KMO talks about whether this factor analysis is appropriate, the significance, right, and exclude. So I clicked all these options. Now here, before we go in detail with the interpretation of the results which we got, I'll show you some more thing. If you have not used it, see, you can see some, arrows here on left and right side. I just want to, now if I want to see the data sheet, what I'll do, I click on this arrow on the left hand side. The moment I click no, all those things which I did got hide, and I can see the data file here complete. I want to go back to my screen where I did analysis. Again, I'll click on it. I got it. Now, if I want to see only results, not this analysis page, okay, only results I want to see, just click on it. Right? Now you can see the complete results here. Fine. Now this is showing a result of principal component analysis. So now KMO, as we all know, the value should be more than 0.5. So here overall sampling adequacy is 0.7, which is better, good to go. Okay, the threshold is 0.5. Now what actually this states? It states that the sample, we had 10 statements, 10 into 10, 100. The sample size is adequate to run factor analysis. That is what KMO means. Okay, Bartlett's test talks about factor analysis, develops a model that you can see in the path analysis. Later I'll talk about it. So whether it's a good to go or not, that is significant. We had a value less than 0.001. Okay. Similarly, this is the test for normality, Mardia's test for multivariate normality. Even though when you go for factor analysis, there is no hard and fast rule to check normality. But if you have a normal distribution, it's better to run factor analysis. Why? Because you'll get better factors, because there is less variation, no, less dispersion in your data. So that can also be checked. And this is a recent addition to this software. In earlier softwares, there is no option for normality directly into PCA, principal component analysis, being because the theory states that there is no need for normality in factor analysis. Then chi-square talks about the model, which is significant. Now this is a very important thing, factor loading and how many factors we are getting. So here you can see that there are how many factors? Can anyone tell me how many factors we got in this?
3 factor.
3 factors,
Three
we got,
factors.
right? Yeah, we got 3 factors. The first factor is a combination of x6, x4, 2 and 7, right? Then second factor is a combination of x5, 1 and 3. And third is a combination of x9 and 10. Since it's a dimension reduction technique, it used to eliminate set of statements which are not relevant, like x8 got eliminated, right? X8 got eliminated. Okay. And what is this uniqueness? Here, this software uses a term uniqueness. In SPSS, SAS, or any other software, you will find out a term called communality. Right? So what is communality? The variance explained by the variable. Higher is the value of uniqueness with reference to the variable. There is a less chance that that variable will get loaded on any of the factor. And this is one of the way.
Sir,
This is
please
one of the.
identify the factors again. How do we identify the sin factor?
Okay, fine. So see, there are three factors as we can see: PC1, PC2, PC3, right? PC1 is a combination of 6, 4, 2, 7. Because here we have a factor loading more than 0.5. Okay, all are positive and factor loading is well above 0.5. PC2, three factors, 5, 1 and 3, X5, X1, X3, again more than 0.5. PC3 we have two factors, but here the interesting part, we have a negative factor loading also. So yes, but we'll include it, the negative factor loading, right? Because it should be more than 0.5, but we have a value more than 0.5, but that's a negative. Why it's negative, we'll look at it, we'll try to understand it, right? So I'll explain all these things. But before we go in detail with this factor part, let's look at the uniqueness part. What is uniqueness? Uniqueness is communality. Okay, so generally, just pay attention to this. It will help you when you are running factor analysis, because generally when you run factor analysis, no, in one go you will not be getting ideal factors. You have to repeat the factor analysis again and again by eliminating some of the statements from your instrument. So how will you get to know that which statement to eliminate? The idea actually of elimination comes from the communality, that is uniqueness. Higher the value of uniqueness, if a variable is having higher uniqueness, that means that variable is having high variance, more error terms, more residual terms, and that's why that is not getting loaded on factor. Okay, you should remove that variable from factor analysis and run again the factor analysis. That should be the idea, and that's why we get uniqueness values. So generally, if the uniqueness is high with any variable, it will not get loaded. If uniqueness is less than 0.5, there is a high chance that that would be loaded on the factors. Okay, so if you want to repeat again and again factor analysis to get a better factor, you simply have to look at uniqueness or communality. Where a communality is high with a variable, just remove that variable and run factor analysis again. You'll get a better combination of the factor. That's the idea. Now, just try to name these factors. If I talk about PC1, PC2, and PC3. So PC1 is a combination of X4, X6, 2, and 7. Okay. I want to name this PC1. What would be the name? So for that, we have to look at the nature of these statements. 4, 6, 2, 7. Okay. Just have a look at the statement. 4, 6, 2, 7. What is 4? Aerated soft drinks should be avoided. 6. Aerated soft drinks are not good for children. 2. Are bad for children. Should be consumed occasionally.
Please keep your mic on mute.
Okay. So in the first factor, we have the statements X4, X6, X7, and X2. If you look at the nature of these statements, bad X2 is aerated soft drinks are bad for health. 4 should be avoided with age, not good for children, should be consumed occasionally. So there is a common thing, right? So we can name it. So what could be the name of the factor?
Health factor.
Yeah, there is a health concern, right? Health concern. Okay, so health concern is one of the factor on the basis of which people choose a soft drink, whether they are preferring or not. This is one of the factor. Okay, now let's look at the second factor. Okay, let's look at the second factor. PC2, X5, 1 and 3. 5, 1, 3. 5, 1, 3.
Dear participant, please mute. Please keep your mic on mute mode. Do not disturb other participants. Please keep your mic.
Okay, so X5, 1, 3. So if I look at X5, soft drinks are very tasty, convenient to serve, and refreshing. So there is something common among these three statements, right? All these three statements are having something common. Very tasty, convenient to serve, refreshing. So can we say that it talks about the product benefit part? The benefit from the soft drink?
Yes, sir. Yes,
That
sir.
is right. So that is there. And if I look at the last part, 9 and 10. 9 and 10 are together in PC3. Now here 10 is having a negative correlation value, that is factor loading. Okay, so we'll look at that also now. 9 and 10, fine. So what is 9? Are not as good as energy drink. Okay, 10 are better than fruit juices. Now can you tell me why you are getting a negative value for factor loading here? Can anyone tell me why we are getting a negative value for factor loading for X10? Because this statement is reverse coded. Right? So if I talk about X10 are better than fruit juices is a reverse coded statement against the sentiment. We framed all questions in one direction. This one is the other one, and that's why we have a negative statement here, negative value here. So people are having a very clear sentiment. So we can name it as a comparative factor because it talks about comparison. So there are three factors that we determined. If you look at it, there are three factors were determined. One is health related factor, the other one is product benefit, and the third one is comparative factor. Okay, so I hope it's clear to everybody. On this data, we got three factors: health related, comparative factors, comparative, and benefit. So second is benefit, first is health related, third is your benefit, comparative, and health related. Okay, three factors. Now just go down and look at this path model. Just have a look at the path model. What this path model demonstrate? You don't have to, if we select this path model while doing analysis, we don't have to look at the tables. We can directly have a look at the path model and get to know that which factors are loading. Wherever we get a darker arrow like RC1, factor 1 is a combination of 7642. Factor 2 is a combination of 531. And then if I talk about RC3, it's a combination of 9 and 10, but 10 is negatively loaded. That's why we have a red arrow. Now, apart from these thick arrows, we are having light arrows also. You can see why light arrows, because all these variables are related with other factors also, but wherever we have higher factor loading, we choose that, right? That's why other also is there, but this is a strong loading. And this is the scree plot. Okay, and this is the scree plot. Scree plot clearly tells that, see, before this eigenvalue 1, at the basement we have 1 as an eigenvalue, and against this eigenvalue we have three factors which are having eigenvalue more than 1, 3, 2, 1, and after that whatever factors are having less than 1, right? So what is the total amount of variance explained by these factors? You can look at this table. Just have a look at this particular table, component characteristics. This particular table, if you look at it, component characteristics, you can see the first factor explains 28% variance, second factor 16% variance, third factor 13. In total, the variance explained by the three factor is 58%, more than 50% variance. That's why these factors were retained, right? So this is what the result for the factor analysis is. Now if we look at the parallel analysis, now let's have a look at the parallel analysis part. What is parallel analysis? Let's say I choose parallel analysis now, and that too on this. So I'll get result for parallel analysis. So what parallel analysis do? Parallel analysis basically validate these factors against the eigenvalue, and it clearly tells you that whether you can retain these three factors or not, right? Whether we can retain these three factors or not. So that can be checked. So you can see that it actually gives us two factors. There are three factors, but two factors are updated here in that. Okay, so this is about the factor analysis part, how you can run factor analysis here. We can you can check the parallel analysis part in order to know that whether we can go ahead with the three factors or we should restrict it to two factors like this, right? So, and apart from this, we can directly copy these results also to any of the Word doc. If you want this, if you want the entire table directly, we can click on it, save as, computer, you can save. Okay, or you can directly go to the export result option, computer, and you can export the results, right? There you will get two options. One is your HTML file, and the other one is JASP file. Sometime it gets saved in PDF also. And if you save it in a HTML file, you can open it in any other document also, Word doc also, Excel also, right? Or if you want to copy individual table, simply double click on it like this, copy. There is an option for copy. You can copy it also, right? So this is what the factor analysis is. This is how we run factor analysis. We got three factors. Now, if I want to take the result of these factors for further analysis, what I can do, I can run regression also. So quickly, I'll show you how we can run regression. So before running regression, let me brief you about what these three are. Here we are having three more things: HRC, BP, and CF. What is HRC? Health related concern. Product benefit is PB, and comparative factor is CF. Okay, what I did, I took mean. I made a cumulative variable. I transformed the variable HRC by adding the values for the statements which are coming under HRC. Okay, so under HRC, what I am getting, see how I got these values. I'll tell you. In under HRC, what I am having, 6x6427. I added all the values divided by 4. So I got this. Similarly, I transformed PB, product benefit, and CF, these three columns. So instead of taking those statements individually, I can transform the variable. This is called transform variable option. You can easily do it in CSV by clubbing the factors, right? Now we can run regression. For running regression, what we can do?
Excuse me,
Uh,
sir.
s-
Yes.
sir,
Sir,
in your PB, why
HR,
the value is more than so high value? It should have been divided by 2 or 3, na PB value. In your PB column, the values are 12, 10, 10. Should have been divided by 3.
Sir, your video is struck, sir.
Nishant sir.
Sir,
Nishant sir. Nishant sir.
sir is not responding, sir.
I'm trying to connect him. Actually, his number is.
Maybe sir would have kept for a hold for a minute, sir.
I
We'll
think
wait
he's
for
calling back to me.
Yes, sir. We'll wait for 2 minutes, sir.
Hello, am I audible?
Yes, sir. Yes, sir.
Okay, okay. Sorry, I lost connection in between because of some issue. Okay, I'll share the screen and there was some query. I'll try to answer it. Okay, let me share the screen first. So I hope my screen is visible.
Yes, sir.
Yeah. So there was some question coming in. By that
Yes,
time, I
sir.
lost the.
Uh,
Yeah, please.
yes, sir. I was asking that the HRC and PV value have it done manually or how you have take out this value.
See, in that, since we know no that under HRC we have these variables. There are two ways to calculate it. See, HRC involves x6, 4, x4, 2, and 7. So you have CSV file. There you can directly apply the formula that is equal to sum of h6, h4, 2, 7 divided by 4. That is one way, right? And then we can calculate for all the variables. Second is by compute variable option. There is an option called compute variable. We can use it that also. If you are using SPSS, there is an option for compute variable.
Yeah,
Otherwise,
yeah.
you have CSV file. In CSV file directly we can do it. I'll just show you
Okay,
the CSV file.
you're saying that you have taken out in the Excel sheet में आपने उसको compute कर दिया and then you're using that variables.
Yeah. That's
Okay.
more easier, no? Instead of that way.
Okay, sir. Okay, thank you.
Okay. So yes.
Sir, why the values of PV and CF are more than the highest value of Likert scale? Because you have said you have taken the average of four or three variables. Then why the values are more than five?
Uh, See, this is the average value. Just check the Excel file. I'll just open the Excel file a moment. Give me a second. Probably there is some error in the file calculation. I'll just open the file. It should be less than that 5-point scale only. It
Sir,
can't be more than that.
I believe you have not taken an average for your PV. It's just addition values.
Yeah, that is a formula problem. This is just an addition of what? Let me check. Okay, so basically this 4.5 which we are seeing here, no, this 4.5 is it is equal to, in HRC what all variables are there. In HRC we have
6427.
okay, just give me a moment. So here some we have H6, then
X4,
H4, 2,
X2, and
and
7.
then 7. Fine. Yeah. So here also the same thing is being applied here. Same formula would be applied there. So probably there is some error with it, with the formula. That's why. So here in PB also we'll use the same formula. Sum. Now PB is a combination of which variables? Could you please tell me?
X5,
X5,
X1,
X1,
X3
X3, right?
divided by 3.
Yeah, divided by 3. So same way we'll apply it. So there is some error in that formula calculation. Rightly pointed out, it should be less than 5 only. Right? And then here also we'll use the same formula. Okay, so that is a combination of 9 and 10.
Divided by 2.
Yeah, that would be divided by 2. So I'll just import this file again to show regression. Okay, so open. Yeah, now it's done, I think. Yeah, it's better now. Fine. So there was some error in the calculation. Now we can go for regression. So again, regression, how the output of this factor can be used for some other technique. I'm showing for one technique, that is regression here. We can go for linear regression here, right? So now the dependent factor here is satisfaction. We can use satisfaction here as a dependent factor, right? And independent factors are HRC, PB, and CF, right? So that was moved to this, okay? And then we can choose the model here, not required. Statistics, we can go for R square. Whatever you need, you can click multicollinearity. We can check model specification. If you need p-value, plot. If you need f-value, that too can be checked. What else you need here? We need a QQ plot to understand it. So what I did, I simply moved the dependent and independent variables into the column. If there is some grouping that can be clubbed under factors, then component, okay. If you need model fit, R square, descriptives also, that can also be checked. If you need collinearity diagnostic, you can click on all these options, whatever we need. Then p-value, if you need results in p-value or f-value, right? So based on that, we can choose, okay. Now residual plots, residual versus predicted or QQ plot to understand the data. Once we click on it, we can see here clearly, right? So this is what the result is. Now, if you look at the model is quite significant. P-value is less than 0.1, 0.001, 0.05. You can see the model is significant. Now, we develop three factors. The point here is to understand which factor is having a positive impact. So HRC, health related concern, is having a direct impact on the choice of the soft drink. And product benefit and the comparative factors are negatively related. But if you look at the significance, health related concern is not significant, right? Okay, but the others are significant. So that way, if you look at it, and comparative factors, yes.
Sir, your R square value is very low. It is only
It's some,
0.395.
yeah, R square is very low. Generally, it's a demo data which I have taken here. So, but again, in social science and humanities, if you get a R square near to 40% or 50%, that is sufficient, right? It's a dummy data just for 100. If you increase the sample size and all, no, we can get a better coefficient of determination. That's why. Okay, so that's the reason. Fine. So we are having unstandardized value, that is CF, and also we can look at these values and significance and how data is distributed. That too can be looked here. Correlation, we can see R is fine. R square is just 39%, but generally we get hardly 50% or 55%. That is sufficient to define the model, right? So this is how we can run further. You can explore other things also into it. If you want to see descriptives, again, the software is quite simple to use. You can select the variables, move here. I'm just demonstrating how you can, hover around in the software to use it for different tools and techniques. How simple and how easy it is, right? You can click on whatever you want. Simply click, you'll get the results. If you want to have some plots, tables, right? Frequency tables, you simply have to click and you'll get the results.
Sir, do you have a SEM feature here?
Yeah, we have a SEM feature here. We have structure equation modeling. Just click on it, and an option is SEM. Yeah, here it is. Right? Are you able to see the option here on the right hand
Yes,
side?
sir. Sir, can you give sir, can you give a quick demo of SEM? How it looks different?
So for that, again, that will require time to demonstrate, because in this software for SEM, we have a scripted code. So I have to demonstrate that how that code can be used for structure equation modeling here. We have to do some changes into the code that needs some time. And that too for a data set where, let me see. if I can show something based on this data only. No, that is actually scripted one. If I start running onto it, no, it will take time to demonstrate first that how SIEM can be used. Probably we may have some other session where I can demonstrate both the covariance and the variance-based sampling, variance-based structure equation modeling, how PLS and that can be used by using, not PLS, this covariance can be used, right? So we are almost 8:53 now, so it's difficult. But reliability and further you can check, you can do some machine learning also here, classification, meta, and all these stuff, right? So further you can export this data wherever you need, and you can perform analysis. So this is how, and again there is a very good example for mixed model that can also be used here. Okay, any questions? So that's all from my side related to the usage of this tool and factor analysis. Yes.
Sir,
Any questions? If you have, I would be happy to answer.
It has also got a feature of R script. So can you just indicate what is that?
Yeah, so basically, if you have scripted, in R, you created one script, no, for let's say clustering or classification. That script can be imported here, and on the data directly that can be used. Or if you have, data file in R, that also can directly be imported into this software. So the R console can be merged here for further analysis. Yes, any further questions or queries related to the session?
Sir, the items should always be positive, sir. Suppose negative comes means that a value coming reduced less than 5. So the item should be always positive, the questions.
No, not necessarily. You may have a negative. If you have a reverse coded statement, no, you'll have a negative value. Basically, that factor loading is a value of correlation. That's a shared variance, no. We can have a negative loading, accordingly we have to interpret it. But we should not have a cross loading. That is very important. We should strictly avoid cross loading, but we can have a negative loading also along with the positive loading, and that can be used for defining factor like we did here.
Okay. Thank you, sir.
Any more questions, participants?
Sir, where do then you use the CFA here in this data? Or do you require to do it, or since you have done a parallel analysis, this is not required?
No, yes, we can do CFA. No, see, you already developed a model. Okay, if you look at the path model, no, path model already gave us, the definition of the constructs. Now, further, you can, work on this model to add few more endogenous variables, and you can take these constructs to the next level for confirmatory factor analysis. We develop the constructs here, no, 3 constructs we developed, which are required for consumer's choice related to soft drink. Now, this model can be tested through confirmatory factor analysis. That can also be done. And this is how, EFA is linked to CFA. That's the next step to CFA. But for CFA on this data, we need to add few more constructs to have a robust model so that, we can have a better understanding. That's also important thing to see.
Hope all the participants, your doubts are clear. So if that's the case, can we move ahead with the closing remarks?
Sure, ma'am.
Yeah. Thank you, sir, for such an informative session. Hope all the participants would have got benefited by all the inputs and insights that has been given. And on behalf of School of Economics and Commerce, CMR University, I thank you, sir, for such a gracious presence and joining us today for enhancing the joy of our learning. And I would like to express my appreciation to our resource person, Dr. Nishant Kumar sir, for joining and today and sharing your treasure of knowledge, sir. And I also want to thank the school, the SOEC team, School of Economics team, for extending their support in smooth functioning of this FDP 6 days program that is on advanced research. And and I also extend my special thanks and great gratitude to our director, Dr.B.B. Tiwari sir, for being part of this session and for being the backbone of the ensuring that the session goes smoothly and providing us all these resources. Once again, all the thanks. So I thank all the participants for being, part of this session, and hope you all had very informative and learning session throughout. Yeah, and with all the closing remarks, I also want to inform you that we have already received all your corrected copies. So participants, please keep your mic mute. There is a